Hello children, welcome back. Let us start our next session today. In this session, first we will discuss about the proverb. As usual, we have developed a habit of it. The proverb that I have selected today is nothing is impossible. So children, usually we will say that it is very tough or it is such a big work which I cannot do. So this kind of things, if we have in the mind, we cannot proceed with our trial at least. If you have a work, at least we should have a trial whether I can do it or not. Just simply by saying, say suppose in your language I will say, suppose the answer is very big. You feel that, it's such a big answer. I won't learn. I can't learn. So you say that it's quite impossible. I cannot do it. You do. You say that. But that is not the case, children. You see how impossible word can be differentiated. You can write impossible as I am possible. So every impossible says I am possible. When impossible becomes possible, when you work upon it. You should have a determination. Any way I should get it. Any way I should do it. When there is a will, definitely there is a way. So, if you have that will, children, everything is possible for you and you can get success in your life. Let us come back to our lesson, children. Now, we are going to talk about 7th class state syllabus, Telangana state syllabus. I am teaching you 7th integers, and today in integers I am going to continue with the next topic. It is there in your textbook page 20. From this page 20 onwards, a few topics I will discuss today. Now, in this you are having, say, properties. Once again you have got properties. Earlier you have got properties under additions and under multiplication. Now we are going to have properties under subtraction. So additions you have done. Now properties under subtraction. As usual, the first property is dealing with closure property. What does this closure property explains to you, children? The closure property says that if A and B are two integers, then A minus B is equal to Z, because you are talking about subtraction. If you see, children, in addition also the same property we have done, but in addition A plus B is an integer we have discussed. Now instead of addition we will be doing minus. So all these formulae or all these properties you can study basing on that particular whatever the addition or subtraction, whatever the property they are asking, you can just say change it, you will get the property, children. No need to buttify the definition all the time. So here, when we have taken the closure property, let me take an example here. In the example, let me take A as 6 and B as 3. What am I getting, children? A minus B means 6 minus 3, that is equal to 3. Suppose if I have taken, this is the first example I am taking, and second example, suppose I have taken A as 3 and B as 6. What is A minus B, children? 3 minus 6. How much you will be getting here? Minus 3. So you say that 3 and minus 3 are integers. So in any way you do, you are going to get this property. So what you will say? Integers are closed. Means what? Closure property exists under subtraction. Integers are closed under subtraction. That means the closure property exists for integers under subtraction. I hope we have followed this, children. You copy this property. Now, we will go to the next property. The next property is commutative property. Closure we have completed, no? Commutative property. In additions we have done a plus b is equal to b plus a. So here if a and b are two integers, then a minus b is equal to b minus c. This you need to see whether it is possible here or not. Let me take a as 6. The value of a I am taking it as 6. And I am taking b, the value of b as minus 4. So let me do a minus b. A minus b, 6 minus, you have another minus b, I have taken minus 4, so I have taken it like this. So 6 minus of minus, 2 minuses, you have to separate with the help of bracket, children. Otherwise what happens if you just only write 1 minus, because if, minus 4 I have taken, 6 minus 4 you have taken. If you write, that is a wrong way of expression, children, because this minus is the minus of the property and this minus is the minus of the value. So be careful. So minus into minus, you'll get plus 6 plus 4 is 10. A minus b is 10. Now let me write b minus c. What is b, children? Minus 4. Minus a is 6. So I can write directly because 6 is having plus sign. Here since 4 is having minus sign, I need to keep a bracket. But here I need not keep like that because 6 is having plus sign. So minus 6 minus 4. How much you are getting? Minus 10. So 10 is not equal to minus 10. Therefore, commutative property does not exist for integers under subtraction. So this property, commutative property, does not exist for integers under subtraction. So I hope you have understood, children, because a minus b will not be equal to b minus a. We have not got property. Commutative property says that if you wanted to say that commutative property is existing, what you should say, a minus b should be equal to b minus a. But are we getting a minus b as equal to b minus a? We are not getting. That means what? What we have done is not it's not possible. Commutative property does not exist for integers. Okay, children. Now let us go to the just copy it. Next, after you have commutative property, we are going to talk about Other properties, children, properties under division. You have for subtractions only these two properties. Now we are going to talk about properties under division. Under division. I have taught you earlier about divisions of integers. When I was talking about divisions of integers, the property which you need to remember is whether the negative sign is there to the numerator or it is there to the denominator, the whole fraction gets a negative sign only. This you should keep it in mind whenever you are doing divisions. Now let me take the closure property in it. The first property is closure. The first property that you have got it here is closure property. So what is the definition once again? If A and B are two integers, then since it is a division, A divided by B should be equal to an integer. Addition means A plus B is an integer. Subtraction means A minus B is an integer. And division means A divided by B is an integer. Suppose, let me take A as 2. As an example I am teaching. And B as minus 3. So A divided by B means what, children? 2 divided by minus 3. That means what you will write here? 2 by minus 3. 2 by minus 3 is nothing but minus 2 by 3. What is this minus 2 by 3, children? It's a rational number. It is not an integer. So minus 2 by 3 is not an integer. Children, be careful. Because there is negative sign, I say that it is integer means that is wrong. If you have just a negative sign is not the thing. Numbers also should not be in fraction form, A by P by Q form. So when you have seen here, it is in P by Q form. It has got a numerator and a denominator. So definitely it is not an integer, children. If it is not an integer, then what you can say? Integers are not closed under division. So in divisions, the closure property does not exist for integers. Under division, for integers, closure property does not exist. This is the reason what I have given. Write down. Now we will go to the next property, that is commutative property. Closure property we have completed. Now we will go to the commutative property. What is this commutative property says? If A and B are two integers, then A divided by B should be equal to B divided by A. So once again, let us go for it and see, is it really possible or not? Let us see about it. So A divided by B. You take some values. Let me take A as minus A as I'll take it as 4 and B is equal to minus 2. A I have taken as 4 and B I have taken as minus 2. So Let me see A by B. A divided by B, that means 4 divided by minus 2. That means 4 by minus 2. 2 ones are 2 twos are. So what you will get to know, this minus will go to the numerator. Minus 2 is your answer. Now, let me go for B divided by A. B divided by A means B is how much I have taken? Minus 2 divided by 4. So when I take minus 2 by 4, how much I am getting, children? Minus 1 by 2. Is minus 2 equal to minus 1 by 2, children? They are not equal. Therefore, commutative property does not exist for integers under division. Because we are talking about division, you have to write this. Commutative property does not exist for integers under division. So, even in integers for under subtraction also we got the same thing, no? A minus B is not equal to B minus A. But when you are talking about a closure property under addition, A plus B is equal to B plus A. So according to the whatever the property that we are using, these values change. They will be changing. So you have to think about it, and you should, if you have any problem, take some example and do it. You will clearly understand, yes, whether I will get it or not. So commutative property does not exist under subtractions as well as it does not exist under division. Okay, write on this. It is second property, children. I have forgotten to keep this number. Second property, write on it properly. Next, after this, you have got the third property, that is associate. Before that, you have got division by 0. Division by 0. We'll go for example directly. Suppose you have got a number minus 4 and they ask you to divide it by 0. How will you write this? Minus 4 by 0. Is it possible, children? You can never divide any number by 0. So, it is not possible. You cannot divide any number by 0. Okay, so the division, the answer that you will be getting, you will say it as infinity. In your higher classes, you will get it. Infinity. Infinity means what? You cannot say the answer. It is not possible, impossible. The division for any number cannot be divided by 0. But what you can say, suppose if you have 0 by minus 4. 0 when you are dividing by minus 4, just it's only an example I am taking. 0 by minus 4, if I take 0 by minus 4 is 0. It is possible. It is possible, children. You can divide any number, means 0 by any number. Here it is possible because you are getting 0. But any number divided by 0 is not possible. You don't get any answer there. Okay, children? This is about division by 0. Now you have got division by 1. You know this pretty well, children. We will take one example, the same minus 1 divided by minus 4 divided by 1. What we are getting? Minus 4 by 1, that is minus 4. So any number when you are dividing by 1, you are getting the same value as the answer. Suppose if you are dividing by minus 1, what will happen? So same example I'll take. Minus 4 divided by minus 1. So what is happening to me, children? Minus 1, its sign is getting changed. So when you are dividing by 1, you will be getting the same value, and in integers, when you are dividing it by minus 1, definitely the sign of the number will change. This is the property, children. If you take plus 4 divided by minus 1, minus 4. But here plus 4 divided by 1 is 4, minus 4 divided by 1 is minus 4. So whatever is the number, same value you will get answer here. But here when you are dividing by minus 1, the sign of the number, I have taken minus 4, I got it plus 4. This you should keep it in mind, children. Copy it. Now, we will go to the next property, that is associative property. This comes as fifth property. Associative property. So what does this property talks about, you children? I told you earlier, association means grouping. So we need to take 3. If A, B and C are 3 integers, then A divided by B divided by C. Division now we are talking about. Keep a bracket, is equal to A divided by B divided by C. Okay. This is the property, children, associative property. If A, B and C are 3 integers, then A divided by B divided by C. That means I have made bracket for A and B. So first you have to do A and B. A divided by B divided by C is equal to A divided by B divided by C. I made B divided by C as a group. So let us take let me take values for A. Let me take A is equal to 16. B, I'll take it as minus 4, and C, I'll take it as 2. These are the values that I have taken. A, B, C values. So let me go for LHS. LHS is A divided by B divided by C. That means 16 divided by minus 4. So I'll put a big bracket here, box bracket, divided by 2. So first what is there in the bracket I have to do? So first I have to open this bracket. 16 divided by minus 4. So again minus 4 means I need directly we will go for the division here. 16 divided by minus 4 divided by 2. 4 4s are 16, children. So minus is there. Minus 4 divided by 2. How much you'll get? Minus 4 by 2. The answer is minus 2. In LHS, you got its value as minus 2. Go for RHS. RHS, A divided by B divided by C. That is, A is equal to 16 divided by B. I have taken minus 4. So, I need to take a big bracket here. Minus 4 divided by C is 2. That means 16 divided by minus 4 by 2. 2 ones are 2 2s. What is there in the bracket? I should do it here. So 16 divided by minus 2 means what, children? 16 by minus 2. 2 ones are 2 8s are. So what is the answer I got? Minus 8 I got. So minus 2 is not equal to minus 8. Is associative property there, children, now? So we will say that associative property does not exist. I'll write it here. Associative property does not exist. Associative property does not exist for integers under division. So this is associative property, children. We have understood that the closure property is not there, commutative property is not there, and associative property is also not there for integers under subtraction. So I hope you have understood today's class, children. We will see the next part in the next class. Bye.